All right, we're going to continue our discussion on angle relationships. This is lesson 2. Learning target is very similar to the one previous. I can solve for unknown angles in word problems and diagrams, just like lesson 1, involving not only complementary and supplementary angles, but also vertical and adjacent angles. So these last two descriptions will be what they're going to add to lesson 2. Hopefully you've gained some confidence on complementary and supplementary. So let's jump right in. Let's go ahead and take a look at this example 1. Two lines meet at a point that is also the endpoint of a ray. So when they say two lines, they're referring to the straight lines that go all the way through this one and this one, and also the endpoints of a ray. So the ray is the one that's a different color, the purple. All right. In a complete sentence, describing the relevant angle relationships in the diagram, set up and solve an equation. So there's two things that we're needing to do here. We're needing to describe and we're needing to set up and solve an equation. So let's go ahead and take care of the words, and then we'll look at the math in a moment. We can observe that we have some supplementary angles that are taking place because of the straight line that add up to 180 degrees. And the straight line we're going to look at is this one. So altogether, that is 180 degrees. So we have 28, 16, and P are supplementary. We're taking care of the describing right now. So we know that those three things add up to 180 degrees. Let's go ahead and take care of the math part. So 28 degrees plus 16 degrees plus this P all add up to 180 degrees. Now that we have an equation, we can combine like terms. And solve. So subtract 44 from both sides. P equals 136. Angle solved for. Now we've taken care of P. Now let's take care of another angle, which is R. And again, we'll take care of the words. We know that P and R both add up to 180. They are both supplementary. Forgot the end. So we'll create the equation. We have P, which we now know is 136. So 136 plus R equals 180. Subtract 136 from both sides, and we have R equals 44 degrees. Let's move on to another example. All right, exercise 1. Three lines meet at a point. So in this case, we have three lines. Extends past the vertex, straight. I'll make that a little nicer. And for the sake of colors, I'll change this last one up. All right, so we have three lines that meet at a point. In a complete sentence, describe the relevant angle relationship and set up the equation. So again, two parts, the describing and the setting up and solving an equation. So we need to observe that we have straight lines. We're probably going to be having 180 degrees. And the 180 degrees I'm going to look at is from here all the way to here, which is encompassing three different angles. So we know that A, and 144 are supplementary. So we know that the equation that we can write for this would be A plus 144 equals 180 degrees. Combined like terms, we have two A's plus the 144 equals 180. We're at a two-step equation. Subtract 144 from both sides. Excuse me. We have 2 A equals 36. Divide both sides by 2. A equals 18 degrees. Past two examples have still only used complementary and supplementary angles. We'll move on to some other examples in the future. This one again, supplementary. So these three angles, angles 19, angles 90, and Z equals 180. Again, only using the supplementary relationship. So for the sake of time, we'll move on to another example. Get something a little different. This one's going to use vertical angles, so we'll take a look at this one. Three lines meet at a point. Angle AOF equals 140 degrees. So AOF equals 144 degrees. In a complete sentence, describe the relevant angle relationship in the diagram and set up and solve an equation. So two parts here. Let's go ahead and describe in words the relationship. And the one I want to focus on is vertical angles. So if we take a look at this angle, or that line and this line, notice that they're both straight lines and they are vertical from each other. And by definition, vertical angles are crossed from each other and they are the same measure. So I know that this angle here has to equal 144 because its vertical angle is 144. So we know that the sum of two things are going to equal 144 in this case. We know that we have a 90-degree angle found here and angle C found here. And this is a one-step equation. We can subtract 90 from both sides. And C equals 54 degrees. Let's move on to another problem. Two lines meet at a point that is also the endpoint of a ray. Line number 1, line number 2. And we've got the ray that comes out from that point. It's important to know that those are lines because we know by definition lines are 180 degrees. So if we take a look at this example, I'm going to focus on the two red lines, and I'm going to note that I have vertical angles here and here, because they are across from each other through two lines. So as far as describing in words, I have 26 and 90, and the 90 comes from this angle here. 26 and 90 are vertical to T. So with that, I can set up an equation that looks like this. 26 plus 90 should equal T. Pretty simple equation here. You just combine like terms, and 116 equals T degrees, or 116 degrees equals T. Two lines meet at a point that is also the endpoint of a ray. Same situation going on, a line and a line. And we have the ray extending from there. The ray is perpendicular to one of the lines, so it is this 90-degree angle to one of the lines. And as far as describing in words go, we have vertical angles that are created by the red lines once again. So I'm going to look at, well, there's another observation. These two vertical angles, 46, and we know this is 46 because these two are vertical. That might help us here. We know that 90 degrees here plus the 46 degrees makes V. So we did use vertical angles to figure out 46, but now we're going to use the idea, well, not even supplementary or or complementary, we're just going to realize that 46 plus the 90 degrees all together forms these two angles, which are defined as V. So combined like terms, 90 and 46 make 136 degrees equals V. Take a look at a couple more here before we close up. 3 lines meet an endpoint, or in a point in a complete sentence. Describe the relevant angle relationship, set up an equation. So again, describing, setting up an equation. We have to notice that 3 lines meet here together at a point. So we have 180 degrees there, 180 degrees there, and 180 degrees here. We also know that vertical angles across from each other are the same. So if this is 8 degrees, then this has to be 8 degrees. And I can't say that that is going to be, well, I could say that this is angle X because it's directly across from that one. Now we're going to use the idea of supplementary angles. So we know that X and 8 are supplementary because they add up to 90, and I will show you that here. So we've got X and 8 are 90 degrees. So these two angles added up equal to 90 degrees. So we'll create an equation. X plus 8 equals 90. Subtract 8 from both sides, so X equals 82 degrees. Two lines meet an endpoint. That is also the end of 2 rays. Let's define our 2 lines. Here's a straight line. Here's the other straight line. And then we have 2 rays coming out of that. We have to describe the relationship and set up and solve an equation. So let's take a look at what we have. The first thing that jumps out to me is this straight line here. I'll pick a different color. This straight line here jumps out to me. Try to pick a different color this time. And I know that all of these angles are going to add up to 180 degrees. So here, I don't know what this is. This is question mark. This is probably going to run into a dead end, but I'm going to trace it for just a minute here to show you why it's going to be a dead end. If that's a question mark, we have to give a variable such as a. So a plus 2x plus 3x equals 180. The equation's true, but there's no way to solve it because there's 2 variables. There's an a and then there's an x. So we're going to have to look at something else. This process is not going to lead us anywhere. The next thing we'll take a look at could be, I see vertical angles, but there's a combination of angles. So still using the purple lines here to show you, I've got 2 vertical angles there and there. These 2 angles added up will equal the same thing here. The reason I chose this is because I know that this one is 90, this one is 25, and those angles have to equal the vertical angles across from it, which include 2x and 3. So take a look at that for a minute and just realize what's going on. 90 and 25 have to be the same thing as 2x and 3x. So if we simplify this equation, 115 equals 5x, divide both sides by 5, 23 equals x. That does not finish the problem. We have to then plug 23 in for x on both of these problems to determine the angles of AOB and BOC. Alright, that should wrap up this lesson, lesson 2.